In today's video, we're going to be taking a big look at the upcoming temperature pattern as well as the current temperature pattern we're in so we can kind of compare that. We're also taking a look at a major snowstorm upcoming in just a few days here, and that one is looking very major, and there's actually been a big twist in the forecast as both of our major models are starting to creep it a little further southward. We need to take a look at that for sure. And then we actually have a colder pattern still left over after that. It looks to be a pretty long-term one, so more snowstorm threats that we're going to be going over today. Let's dive into things, and right now we're taking a look at the current surface air temperature forecast for literally 24 hours from now, about tomorrow morning. So it's actually less, Friday here on the 9th. I want to show you the difference between the surface temperatures and the temperatures just above the surface, and why I've been kind of using a little bit of the air temperatures that are just a little bit above the surface to use a more accurate forecast. One of the things is we can't tell really where the major air masses are here over the ocean. This is one of the flaws with the surface temperatures. As you know, that ocean surface temperature definitely the water temperature influences the air temperature right above it. So we end up actually getting a pretty averaged out look where it's hardly above normal here. Hardly below normal down here, a little bit below normal there, a little bit above normal here. And then once you get over land, you're getting more of those extremes. That's not because air is different over land, air masses, that is, upper air masses. It's because that surface water temperature is impacting the air temperature when you're looking right at the surface. But when we're looking at actual troughs and ridges, we actually have some more extremes going on. Here's the upper air pattern. This is at the 850 millibar height. But what we get is more extreme warmth in this area, more extreme colder temperatures underneath, more extreme cold air here as well. And you're really getting a more accurate representation of where those troughs and ridges are. So is it good to represent the actual surface temperatures? No, but what it is good at is registering where those troughs and ridges are, which is going to help us to dictate where the colder air mass is, where the warmer air mass is, and also where these storms are likely to navigate between these. So it's a pretty interesting comparison here. And again, this is right around now, and what you see is that there's a very, very warm air mass here over the eastern regions of North America, both in the United States and for Canada. We have these above normal temperatures sitting over the eastern regions, and a very, very cold one here for the western regions of North America. So definitely it's a negative PNA pattern. What that means is we have this colder air sitting here, and really all the warm air is surging northward into the east because it's all centered over the west, the cold air that is. So all of this warm air that would have been over Mexico and some of the Pacific here is kind of navigating its way into the eastern states. And what we're going to take a look at here in a second, I'll show you. But first off, I want to talk about the AO here, because this is a negative AO. Arctic Oscillation is what it's called. And basically what this means is we have warmer temperatures over the Arctic Circle. So that is forcing the Arctic air southward towards more middle regions here of the hemisphere. And we see these colder temperatures actually pretty spread out here. They're not everywhere, but they're definitely more prominent there as you head further towards the equator. And that's classic in a negative AO. If all the cold air was bottled up in this area in the Arctic, then you would likely see pretty persistent warmth all around these middle layers, but it's not what we have here. I want to show you what a positive PNA looks like, and this is the forecast of those upper air temperatures for Saturday on February 17th, and we see quite the opposite actually, warmth along this western region, and this would be a positive PNA that stands for Pacific North American Oscillation. And now, instead of the warmth moving away and into the east, it's moving actually straight northward into the west. And what's happening is we actually see the cold that would be over Alaska and portions of Canada here pouring into the eastern states. So you can tell it's really, really quite the opposite. And we're left with a colder temperature pattern here, actually from about the 12th onward through basically the rest of the forecast period. So definitely a prolonged cold air mass is what we expect at this point. Let's just break down our typical stuff here. I mean, we're going to go over the European model. I want to take a look at this upcoming snowstorm. And again, we start out here on Sunday, the 11th. For this potential upcoming snowstorm, and we see a 1004 millibar low pressure center over eastern Texas. What this causes is snowfall to the northwest here for portions of New Mexico, Texas, and Oklahoma, a pretty far south central snowfall event there. And what we have here to the east of it is thunderstorm activity up and down your deeper south areas and into the southeast right there. Pretty classic stuff for this very far southern wintertime low. Now, as it surges northward, this is by the time we're taking a look at Monday, February 12th, just a day later, we see it is down, I can't see the exact millibars, but I think it's a 995, and what we have is snowfall happening across Missouri, into Illinois, into Indiana, and into Ohio, and then again, those thunderstorms and heavier showers across the southeast still. Again, still pretty classic and very much in line with a lot of the storms that we've had so far this snow season. By the time we're reaching Tuesday here on the 13th, what we see is this low is located just offshore of New Jersey, a little bit further south than we originally saw in this European model yesterday. We have heavy snowfall for central and northern Pennsylvania, a lot of New York here, and then southern New England. Mixing near the coast there of southern New England, does that seem familiar for you guys that live there? Absolutely. That's what we've seen almost every snowstorm this year, and we've also almost every snowstorm this year seen them move up into the Ohio Valley, and then transfer offshore of the mid-Atlantic, and then continue kind of offshore from that point. This is really, really in line with what we've seen a lot of so far this winter. And by the time we reach kind of the later morning, this will probably be about 9 or 10 a.m. there on Tuesday, February 13th. We have heavy snowfall for a lot of Pennsylvania, northern New Jersey, all of the state of New York, and then southern New England there. Very, very heavy snowfalls. This low is down to a 983, which is severe. That's pretty strong, especially this time of year. Now, as we continue this on, it does eventually come to an end, of course, and what we're left with is, again, colder air in the east, as you can see. We still have this higher pressure and warmer temperatures out west. What this is doing is it's first off directing a lot of these storms onshore to the northwest instead of the southwest. Not only that, it's helping a lot of this cold air to pour into the east as opposed to the west. So that is the pattern we're left with by the time we're taking a look at the 15th. And as we continue on, we get a couple of minor snowstorms, but again, we're left at the end of this model run with a surging low in the south central states, which is exactly what we saw yesterday. Colder air left over here in the east, and probably we're going to be looking at some sort of combination here where these all come together for a potential next snowstorm. Let's take a look here at the GFS model. I'm curious about this one. I always watch these with you guys, by the way. I never, I like seeing it and being surprised by it as I'm talking to you guys about it. I think it creates a pretty interesting video as opposed to me kind of ahead of time, planning out the video and, looking over it first and then kind of showing you guys something that I already know all about. It lets me be a little bit surprised, break it down with you guys, and you guys are always seeing it with me for the first time, which I think is really, really cool and a different approach than what you get from a lot of other sources. So anything I can do to differentiate myself is always going to be my strategy. We see that this low moves in much further south here on the GFS model. And if you recall yesterday, I mentioned to you guys that the GFS model has a southeast bias where it tends to just show these low pressure systems too far to the southeast. And I think that's happening again here, even more extreme today than yesterday, as this one really just slides into North Carolina. Again, by this point, I'm going to draw it in a different color. We'll do it in yellow here, but the European model had it almost head northward from this point, and we're looking at, as opposed to yesterday's agreement that we saw, we were bragging about just the great agreement that the European and GFS model had. Now we're taking a look at hundreds of miles of a difference here between the European and the GFS model, unfortunately. And I say that because this creates some conflict in the forecast and some unclarity. So we've actually taken a little bit of a step backwards. The thing we're still confident in, though, is that there will be a snowstorm. So keep that in mind. It's just the location and amounts are a little bit more uncertain than they were yesterday because of these recent changes. Typically, when we see them come into agreement, they don't separate again like they have here. So it does happen sometimes, but a majority of the time they come together and they actually stay together once they've reached that agreement. In this case, we've seen them kind of apart, together, now back apart again. Now we're waiting for them to once again come together, unfortunately. So that puts us in a little bit of a tricky spot. Let's see what ends up happening. We see this low just move straight offshore of kind of the Delmarva, kind of southeastern Virginia as well. And what we get is snowfall for northern Virginia, West Virginia, Maryland, DC, the Delmarva, southern Pennsylvania into New Jersey here, and this is so much further south than the European model. We actually get a severe snowstorm here for a lot of these mid-Atlantic areas, though. And what ends up happening is New England gets dodged entirely, so you can see how this difference in these two models is a make-it-or-break-it difference. It's the difference between, the GFS model solution shows no snow for New England and all snow for the mid-Atlantic. The European model shows almost no snowfall for the mid-Atlantic and all snowfall for the New England area. So huge differences and implications here. And, the certainty is really struggling at this point. We do get another nor'easter system around the 16th here. So this one we get for New England, so they do end up getting some snow according to this model. And we continue to see these cold air masses move down. Also keep in mind, this was the same thing yesterday, but we do have this very far south central or deep south low developing while we have cold air located in the east. Remember, we just talked about that on the European model, and we are going to likely see these come together here. As we can see on the GFS model, it slides up the coast, and we actually get a classic southern slider. I think the GFS, we talk about the southeast bias. We're probably dealing with some of that here. But this is a pretty classic storm track. I would say maybe instead of this, if we take into consideration the southeast bias, if we were to take a look at a legitimate threat here, you'd maybe be talking much more about the classic mid-Atlantic areas, as Northern Virginia, West Virginia, Maryland, maybe Southern Pennsylvania into New Jersey is a more realistic outlook for this type of a setup, and then maybe portions of Kentucky, Ohio, and West Virginia getting involved as well. That might be a little bit more of a realistic area to take a look at this snowfall as opposed to this further south solution. Not saying it's impossible, but I'm taking into consideration that the GFS model, again, has that southern bias. Also, another interesting thing on this frame is, again, we have more western storms moving onshore, bringing more snowfall to the Cascades and Sierra Nevadas, or better yet, Sierra Nevada there by Sunday into Monday, 18th into 19th. We see this nor'easter really hangs out by the coast. It's only a 994, which is relatively strong, just nowhere near that first one. It stalls out, hangs around, there's plenty of cold air, and then it does eventually move out, however. We see a brief warm-up, and then more cold air is on its way here at the end of the model on the 24th. So again, a pretty prolonged period of cold air as we still see more Arctic blasts moving in by this point. Let's take a look here at the total precipitation, and we do have plenty for the northwest. But again, with the high pressure in the southwest, we're starting to see those amounts get lowered as most of the storms move over that area. And then we also have a lot moving underneath here as this flow into the southeast takes place as well. Total snowfall in the European model, we will zoom into the northeast in a moment, but we see out west, tons of snowfall expected. Also for the south central into the Ohio Valley, and then eventually into the northeast with that upcoming snowstorm. Let's zoom into the northeast here as I want to show you guys what we're seeing here. And there we go. We switched to an outdated model run here. So let's move this ahead. And there we go. So this is the total snowfall through that model run. And as you can see, we have a 1 foot plus potential snowstorm. This is pretty classic stuff, that northern Pennsylvania, southern New York, and then southern New England look. Again, pretty in line with what we've seen a lot this season. And then we have that mixing going on for the more coastal areas here of southern New England into like Long Island, New York City, and northern New Jersey. I feel like this is a pretty good solution. I think the amounts might be a little bit off. We might be looking at a little bit less. Here, maybe closer to 10 inches as opposed to those 12-inch plus amounts, but relatively close to my thinking with this storm here, what we're looking at on the European model. The GFS model, however, we will break it down in a minute, but we see out west here, there's tons of snowfall out west, of course. Again, the Ohio Valley still seeing some of that snowfall from that initial system. And then as we move into, I'm just going to do the whole east here. What we see is, I'll move it back to where we don't have that second storm on screen so we can just see our original snowstorm here. But what we end up getting, and I might be able to zoom us in actually to the mid-Atlantic area here and get a good look. There we go. So it's instead of these areas up north for New England, as you can see, we're seeing like Pennsylvania, West Virginia, Maryland, Northern Virginia, Delaware, into the, Washington, D.C., then Delaware, and then into southern New Jersey. But I think this is way too far south. I think that it's going to be significantly further north like the European model is showing. You know me, I don't consider anything an impossibility, so it's certainly possible, just not probable for this very far southern solution to take place. Let's go ahead and add on that kind of bigger snowstorm that happens after, and that would be for here, as you can see. That kind of nor'easter one that we see later on, I think it's a little too far south or maybe a little bit overdone. But I certainly think that maybe more of a mid-Atlantic special like Northern Virginia into West Virginia, Ohio, Kentucky, Pennsylvania, Maryland, Delaware, and New Jersey. I guess a better way to put it is maybe where it's showing the first snowstorm is where I think that second one would be likely to be. And then the first one I think would be much more likely to be where the European model is showing it. I know this is getting confusing, but really confusing pattern we have here. So anyway, guys, that's the breakdown of the upcoming temperature pattern, this upcoming big snowstorm, and then some other snowstorm possibilities that we saw. Be sure to subscribe. We do upload every single day. You can even hit the bell icon for daily notifications when I upload so you never miss one. Be sure to like the video if you did enjoy it, leave a comment down below, and I'll see you guys in the next video.